Hello, I'm Charles Anderson. I'm a chemical engineer who's been using Excel for quite a while, and I thought I'd make some recordings of some of the tips and tricks I've picked up along the way in the hope that they're useful to other people. What I'm going to talk to you about today is how you pass ranges from Excel into Visual Basic and then get range back from Visual Basic and put it into Excel. Visual Basic for applications is the macro language used by Excel. It's really powerful. If you haven't learned it, I encourage you to look into it. It's fairly intuitive. It's a great language to make stuff happen. But if you're watching this, I'm assuming you already know how to use at least the basics. What I've got a reaction system then where I've got A goes to B goes to C. So if I look at the concentration, A drops over time as it's consumed. It forms B, but as soon as B is formed, some C starts forming as B reacts into C. So you get a maximum concentration of B. And I'm going to maybe want to look at where do I get that maximum as a function of time and temperature in the system. I've set it up with simple Arrhenius kinetics. So I've got my rate constants at a reference temperature, the activation energies, the reference temperature, the temperature itself. So then I can come over here and I can get the rate constant for the two reactions at the given temperature. So the magic happens here where I integrate over time. I start off with a given set of concentrations, and then here I've got a function that returns the next row of the data. So let me show you how I set that up in Visual Basic. It's this next row function. So in order to return a range to Excel from Visual Basic, you have to set the variable up as a variant. It can't be a range, it's got to be a variant. You don't have to declare it. I get overzealous in declaring my variables sometimes. So I'm passing y in as a range. I'm passing in the time, the delta t, and a string with the derivatives of the rates of reaction that I'll explain in a minute. First thing I need to do is convert this Excel range into an array, a 1D array in Visual Basic. So what I do is I create I redimension my array to be the size with the number of units in it as there are in Excel, remembering of course that Visual Basic counts from 0, not from 1, so I have to discount the size of the range by 1. I then, for each element, for each of the cells in the range y, I'm going to set y0 to equal the value in that range, and then sort of run through my whole array doing that. I then create a second dummy array, y1, which is going to have the array of variables at the next time step from the integrator. I pass those two arrays into the Runge-Kutta method along with the delta t, and then I get my results out of that routine as y1, again a one-dimensional array. I have to convert that one-dimensional array back into a form that Visual Basic can handle. I have to therefore use this dummy y1. I can't pass next row into the RK4 routine. That would confuse it. So you have to pass y1 and then use this equation to switch them back over again. So one other thing I'll show you while I'm in here is, because it was kind of cute, is my RK4 method is general. I can integrate any set of ordinary differential equations with that. But for each of those, I have to supply a set of derivatives that match the range that I'm passing in and getting out. Since I don't a priori know the size or the derivatives, what I do is I pass in a string with the name of a function that I'm going to call, and then I use the application call method to pass these two arguments into whatever function I name here in my dir call. So you'll see what I've got down here is I've got a couple of different derivative functions, one of which I was using to test it, so I'm just using fixed values for the rate constants, the other of which I'm picking data up from my test sheet and passing that into a set of equations that I can then use to return my derivatives for dy by dt, the rate of change of y as a function of time for my three variables a, b, and c. Okay, so then I come back into Excel. This is my range of inputs. Here's my function that is going to return. You'll notice that it's got these curly brackets around. For functions that return an array, what you have to do is you highlight the cells where you would like the results to be put. You type in the formula as you would normally, but then rather than hitting enter, you do Shift Enter, and that writes the whole array into your new set of cells. You can then copy that down to get the dy by dt information. This is just me checking to make sure I haven't made a mistake. So I can get an explicit rate of decay of A, so I can get the error and so on. Don't worry about that. What I've done over here, though, is I've got a repeat of the time using this time, because what I wanted to do was work out at what was my maximum concentration of B, the product that I'm interested in, and at what time do I get that maximum. And so what I'm doing to get the maximum is obviously just taking the max of the column. To get the time, I'm using the Vlookup function, and Vlookup requires me to have the index data in the first column. So I've set it up this way because this is not sorted alphanumerically, because it's real life data. I use the false argument at the end, the optional false argument at the end, to force it to be to find it regardless of where it is. It's forcing an exact match. This Vlookup function is a subject of another video. If you're interested, you can go have a look at that other video. As long as I have your attention, I'm going to do one last thing. I'm going to use the what if analysis over here. There's a couple of different cool things here, but I'm going to use the scenario manager. There's another video where I mentioned the data table. In this one, I'm going to use the scenario manager. And what I've done is I've set this up ahead of time, but basically what I can do is I can add new scenarios where I have my base case. And if I edit that, you can see I can come in and I'm changing the value of B6, the temperature of the system, and I can give it different values as I set the thing up. There you go. The base value is 75. So this is what happens if it's at 75. If I run at cooler temperature, I'll show that result. You can see that it's now changed temperature to 40. And you can see that the maximum concentration of B has gone down and the time to reach that maximum has gone up. Or I can go to a near boiling and that'll give me what happens at 99C, and you can see that my maximum concentration has gone up and it's happening even faster. Scenario Manager is quite a useful tool if you've got 3 or 4 cases that you want to look at and you've got your whole Excel built up. You can also run the summary tool. I'm going to run it as a separate table, and you can see there what it's doing is it's showing me how it's varying B6 from its current value, the base case, the cool, and the boiling, and what those different values are. So it's capturing those results kind of nicely. It's kind of a cute little feature of running multiple different versions of the same model. Okay, that's it. Thank you very much for your attention. I greatly appreciate any feedback or comments or any other suggestions or tips for stuff that I've missed. Thank you.